with some practice problems. Here's the first one. I used the simulation in the last video to look at how narrowing and widening the tube affects things. And I've got some speeds here. You notice at the left spot, I have a speed of 1.6. And in the narrow spot, I have a speed of 6.4. That's 4 times as much. What do you think the cross-sectional area is at the narrow spot in comparison to the wide spot? So I've got a speed 4 times as fast, so the cross-sectional area must be a fourth as much. But here's the way that you need to really focus on this, because they may not ask you what the cross-sectional area ratio is. They may ask you what the radius ratio is. What I mean by that is, like, if this has a radius of, let's say, 1 meter over here on the left, what's the radius? The radius, like, or I guess I'm saying in this case, the diameter. What's the diameter here? Well, I can't say that it's a fourth as much, because if the diameter is a fourth as much, the area is a 16th as much. So in this case, what happens is that my diameter is going to be half a meter. If I halve the radius, I quarter cross-sectional area, because our equation for area is pi r squared. Very important. In the next example, I've got narrow tube on the left with a speed of 1.6, a wide tube in the middle, and you notice that the speed is a fourth as much. That means that the area should be 4 times as much if the cross-sectional area is 4 times as much. But you notice it doesn't look like the diameter is 4 times as much, because the diameter is only 2 times as much. The radius is only 2 times as much, because if I square something twice as big, it's 4 times as big. So the cross-sectional area at 1.6 meters per second speed in comparison to the speed at 0.4 meters per second, that ratio of the areas is 4 times as big cross-sectional area in the middle of this tube. But the radius is only twice as big, because it's pi r squared.